All right, so like I was saying, we have a total of 7 exponent rules, and we're actually going to do 4 of them first, and then we'll take a little break to do some of our work, and then we'll come back and do the last 3. So our first exponent rule is what we do when we multiply powers. So what do we mean by multiplying powers? It's when we take a base to a power and we're multiplying the same base to a power. How do we combine that to just be one?
A and a, or A and the square root and the square and
Power?
power, yeah.
You're close. You're mixing, it's a different one. What you said is a different one. M plus n. So this is the one where we just add the exponents m plus n. Multiplying them is the next one we're going to do. So when you have like bases being multiplied, you would just add the exponents to combine it. So if I gave you the example 12 to the 4th power times 12 to the 3rd power, what would that equal? So is the base the same? Yeah, what is the base? 12. So the base is what's being raised to a power. They both have a base of 12, so that means we can add the exponents. So what's 4 plus 3? 12 to the 7th, and that could be your answer. Our next one, negative 5 to the negative 2 power times negative 5 to the 7th power. So is the base the same? Yes, it's both negative 5. So we're going to add the exponents. And we want to make sure this negative 5 stays in parentheses because that negative has to be raised to the power, so it has to stay grouped together. So we'll have negative 2 plus 7. So what's negative 2 plus 7? 5. So then negative 5 to the 5th power would be our answer. Okay, if we look at number 3, what do you think that one would be?
5x 13.
Okay, 5x to the 13th. Did anyone think something different?
Oh, 6.
Because why?
Oh, isn't it like 1x on the other side?
It is a 1, yeah. But are we adding or multiplying?
Oh, no.
Okay, so one of the things that you want to be careful about, and I'm glad that no one said something else, really, it is 5x to the 13th. Do you see how this was grouped together, the negative and the 5? Here, the 5 isn't grouped with the x, so we just treat them as separate bases. So we would multiply constant with constant and then add exponents of x. Alright, let's try a couple that are a little more in-depth or involved. Yeah.
Wait, why didn't you add number 3? Wait, did you add?
Yeah, we added
Or you just didn't show it?
there's the number 5. That's just the number. It has an exponent of 1. There's no other base 5 anywhere to add an exponent to. So the only base that was in common was x. So I add the exponents of x. 4 plus 9 is 13. Robert.
to the power of 3 y to the 7th.
Okay, I agree with the y to the 7th, but I don't 100% agree with x to the 3rd. Because what's the exponent of x over here?
Just
1. So what do we have to do?
Add 'em.
We have to add 3 plus 1 to get 4. So remember, when you don't have an exponent written, we can write a 1 in as a placeholder to remind us we have to add 1. Okay? 2a to the 2/3 power times 3b to the 1/4 power times a to the 1/3 power times 5b to the 1/2 power. So fractions can be exponents. It doesn't change our rules. We just have different types of numbers that we are adding together. So the first thing I would do is take all of these numbers that don't have like bases and multiply them together. So what's 2 times 3? Times 6, and 6 times 5? So we'll have 30. For a, we have a to the 2/3 and a to the 1/3. So what's 2/3 plus 1/3?
1.
Just 1. So we'll have 30a. And then we'll have b to the 1/4 plus 1/2.
3/4.
Okay, so if you need to over on the side, you can add them together, get a common denominator, to change 1/2 to 2/4, and you would get 3/4. Okay, any questions about that property? Because that's really all there is to it. It's just whenever you see the same base being multiplied, you add the exponents together. No questions so far?
Can you do that again?
Which one?
Just everything. Number 5.
Okay, so I started with the numbers. So 2 times 3 is 6, times 5 is 30. And then for a, I have 2 a's. I have an a to the 2/3 times a to the 1/3. They're being multiplied, so I add the exponents. So 2/3 plus 1/3 is just 1. We don't have to write the little one, we can just write a. For b, we have b to the 1/4 and b to the 1/2. So we have to again add the exponents, 1/4 plus 1/2. Some people can do this in their head or can easily do it. If not, just write it over to the side. I got a common denominator, so I multiplied top and bottom by 2. So 2/4, so that I can add my fractions. 1 plus 2 is 3, so 3/4. Okay, our second property is called power to a power. Power to a power is when we have a base raised to a power raised to another power. So a to the n power to the n power. How do we combine those exponents when we have a power to a power?
A and n.
This is the one where we multiply them. So m times n. So if we had something like n to the 4th to the 7th, multiply a power to a power, so n to the 28th. So on number 7 here, what is that going to be? We have a power to a power. So how do we combine those?
What is the common denominator?
Are we adding them or multiplying them?
Multiplying.
You only have to get a common denominator when you add and subtract. So how do we multiply fractions? So 1/3 times 1/2. We just multiply straight across. So we end up getting x to the 1/6. Okay, and what about this last one? Y to the 3rd to the 4th. So this will become y to the 12th. Okay, that's all there is to the power to a power. You just multiply the exponents when you have an exponent to another exponent. So any questions on that one? Okay, so let's see, our third one is called power of a product. The power of a product is when you have things that are being multiplied together inside parentheses with an exponent outside. So when we have things being multiplied together with an exponent outside the parentheses, what do? Anyone remember from 8th grade? Yep, you put that exponent to everything being multiplied. So A would have an n power to it, and B would have an n power to it. So if we had 5 x, y, z to the 3rd power, how can we simplify this?
5 z.
So 5 to the 3rd, x to the 3rd, y to the 3rd, and z to the 3rd. And then because 5 to the 3rd is one of those that we can actually do and get a relatively small number, what is 5 to the 3rd? Does anyone remember? 125. So 125, x to the 3rd, y to the 3rd, z to the 3rd. Next one, 7m to the 9th to the 3rd. What was that, Robert?
7 to the 3rd, and then m to the 27th.
Good. So when we put the 3rd on the m, we end up with a power to power, and this happens a lot. So because when the m already had an exponent to it, we'll have 7 to the 3rd, m to the 27th, because we'll multiply them together. Does anyone know what 7 to the 3rd is? 343. Okay, number 11. m to the 1/5 power, n to the 1/2 power, all to the 10th power. So again, we'll take that 10, put it to each thing being multiplied, which gives us power to power. So what's 1/5 times 10?
2.
2. And what's 1/2 times 10?
5.
5. And that would be your answer. Okay, so any question on power of a product? A lot of the time when you do a power of a product, you end up with this power to power somewhere. So as you get comfortable, do you have to write this step here in the middle, or could we just multiply and go straight here? Yes, but I want you guys to get comfortable enough to do that before you jump there. Okay, our last property. Doesn't really have a name. B to the 0 power equals what?
1.
1. Whenever your exponent is 0, the whole thing becomes 1. So if I had something like 5x to the 3rd, y to the 4th, a to the 10th,
All crazy.
c to the
6.
6th, all to the 0 power.
1.
All of that will equal 1 because of that 0 on the outside. Okay? If you had something like 5x to the 0, y to the 3rd, what would that equal? So,
Y to the 3rd.
So the y to the 3rd will be there, but so will the 5. Because only the x to the 0 will become 1. Everything else will stay there. So you are going to have some 0 powers thrown in as well. Okay, so this is about the halfway point of today's lesson. So are there any questions on any of these properties so far?